Assalamu alaikum wa rahmatullahi wa barakatuh. So the concept of digital input and output ports is explained in the previous video. So here in this semester, since we are using PIC 18F45K80 microcontroller. So once again, the input and output ports can be configured using the twist register, 0 for output and 1 for input. And whenever we send a data to the output pin, we can write the data or we can send the data to the latch register of the port register. So when we write the data to the latch register, it gets stored in the data register, and when the twist is configured as an output, so this buffer will be activated and data will be transferred to the output pin. Similarly, for the input, we read the input directly on the port pin of the port register, and the data is transferred here to the data bus from the pin. And if we read the latch register, then instead of getting the data from the port pin, we get the data that was stored in the data register from here. So this concept is already explained in the previous video, and example 1 explains how to configure RB4 as digital input using the TRISC-B register and RB5 as digital output using TRISC-B register bit number 5. So BSF to set as 1 and BCF to clear the bit. Now in activity 1, we have to switch on the LED connected on RD6. So the first step is to configure RD6 as an output pin using the TRISC-D register, and then the second step here is to send a data 1 on the RD6. So you can use either latch D or port D. You can use either of these two registers to send a 1 on RD6 pin of this microcontroller. So the program template is already given here. You just have to fill these two blanks to complete this activity. Now this is the simulation of the first activity, and you can see the LED connected on RD6 pin is switched on. In the second example, it shows you how to configure RA7 as an input, RC5 as an output, and to wait for input to become 0. So bit test file register is keep it clear. This will check the input on RA7, and we have go to wait written here, so it keeps running this loop as long as RA7 is 1. So when it becomes 0, it will skip the go to instruction. It will come here and it will switch on the LED of any other output device connected on RC5. So this is for checking an input and sending an output based on the input condition. So this is like an if statement. So if RA7 is 1, it will keep waiting, and when RA7 becomes 0, it will come out of the loop and it will send a 1 on RC5. Now in the second activity, we are simulating a real life example of interfacing a tilt sensor with the PIC microcontroller and a buzzer as an output. So the tilt sensor, it sends a 0 whenever there is a tilt, and by default the input is 1. So as soon as there is a 0, as soon as there is a low input, we have to send a high signal to the buzzer to sound an alarm. So if there is a tilt detected, we have to sound the buzzer. So we have to sound the alarm. So once again, let us see the simulation here. Okay, so in the simulation, We have replaced the tilt sensor with a push button. So this is just an example. We can use any input, any digital input, any sensor that gives you a low signal or a high signal as an input to the microcontroller. So in our example, in the activity we are using a tilt sensor, and in the simulation we have replaced the tilt sensor with a push button. So by default we get an input because this is connected in the pull up. This is connected as a pull up input. So we get a 1 by default, and when the button is pressed we will get a 0 here. And on RC5 a buzzer is connected with a 220 ohm resistor which is connected to the ground. So let us see the working here now. So as soon as this button is pressed, we get an input 0 and the microcontroller is sending a 1 on RC5. So there are two loops here. The first loop waits for the button to become 0. So when it becomes 0, it sends a 1 on RC5 to sound the alarm, and now it is waiting in another loop, waiting for the input to become 1. So when the input becomes 1, it stops the alarm by sending a 0 on RC5. So this is the simulation. Now let us look at the actual connection on the breadboard and the working of this activity. The hardware connection is as per the schematic shown here. So the MPLAB snap is connected as shown in the previous tutorial on using MPLAB snap, and we have the tilt sensor connected as an input on RS7, which is pin number 13, and the pin of the tilt sensor, the input pin of the tilt sensor is pulled up using 10k resistor. It is pulled up to the VDD 5 volt, and the other pin of the tilt sensor is connected to the ground. On the output side, we have RC5 connected to the positive pin of the buzzer, and the negative pin of the buzzer is connected to the ground using a 220 ohm resistor. We also have the same LED connected on RD6 using a 320 ohm resistor. It is connected here. The anode is connected to the resistor side, and the cathode is connected to the ground. Now since we are using two separate breadboards, so we should have a common ground between these two breadboards and the common VDD connected here. So here we have the connection on the breadboard. The input pin RA7 is connected using this blue wire. It is connected to the input pin of the tilt sensor, and this is the tilt sensor. You can identify the tilt sensor by looking at the number given here. The part number shown on the tilt sensor. The part number shown on the tilt sensor is 520D SW520D. So this will be in the same packet. This will be found in the same packet of the capacitors, push buttons, LED. So connect one pin of this tilt sensor as an input on RA7, and that same pin is connected using this resistor. It is connected to the power, and the other pin of the tilt sensor, it goes to the ground. So you can see the white wire. So this is the other pin of the tilt sensor which is connected to the ground. And then on the output side, we have RC5 connected using this yellow wire. It is connected to the positive pin of the buzzer. So use this buzzer. You'll find the positive pin is indicated with this sign here. So connect the positive side, connect the positive pin of the buzzer to RC5, and the negative pin is connected using this 220 ohm resistor. It is connected to the ground. And we also have the LED connected on RD7, RD6. The LED connected on RD6. It is connected to the resistor here, 330 ohm resistor, or you can also use 1 kilo ohm resistor, and it is connected to the anode pin of the LED. And the cathode pin of the LED, the other pin, the cathode pin of the LED is connected to the ground. And we have common ground connected between this board and this board, and we also have common VDD connected from here using this orange jumper wire. Now let us switch on the circuit. Let us connect the battery now. So first make all these connections, make sure everything is all right, and follow the schematic diagram. Follow the schematic diagram to make sure the connections are correct. And then at the end, let's connect the battery. So this is LM7805. Pin number 1 is still not connected, it is open. Pin number 2 is connected to the ground, and pin 3 is the output 5 volt, which is connected to the positive line on the breadboard. Bismillahirrahmanirrahim. Okay, so the microcontroller is powered up. You can see the tilt sensor is stationary, so you don't see any output here. Now, as soon as I tilt the sensor, you can find, see, as soon as I lift the sensor, it is tilted, and you can hear the buzzer sounding, the alarm, and the LED is switched on. So if I place it back, again it is off. So the buzzer is off now. If I tilt it again, you can hear the buzzer sounding, the alarm, and the LED is switched on. So once again, this is the view from the other side of the breadboard. So you can see this, the sensor is stationary now, and there is no output. And when I tilt the sensor, you can hear the sound, and the LED is switched on. And if I place it back, it is off. So this is how it works. So complete the activity and submit your solution, and submit a picture of your breadboard, your connections, and the complete program code for both these activities. Wassalamu alaikum wa rahmatullahi wa barakatuh.